As you're looking to the sky in a warm summer night, a brilliant point of light catches your eye. It's not a star, but Venus, our cosmic next-door neighbor. For centuries, this dazzling orb has captivated us, earning nicknames like the Morning Star or Evening Star. Ancient civilizations spun tales of love and war around it, never dreaming that one day we'd unravel its mysteries. Fast forward to the 1960s. As the Cold War raged, humanity turned its gaze skyward. NASA's Mariner 2 and the Soviet Union's Venera 4 pierced Venus's veil, revealing a world that defied expectations. Gone were the fantasies of a lush, Earth-like paradise. In their place, an inferno of acid clouds and crushing pressures. But how do you truly see a planet shrouded in perpetual cloud cover? That's the riddle we're here to solve. Join us to see how our impression of our neighbor went from the first grainy images to cutting-edge radar maps. We'll dive deep into the layers of Venus's atmosphere, each more extreme than the last. What are we going to find there? Imagine you have a twin sister. You're the same height, same build, even born just minutes apart. That's Earth and Venus, cosmic sisters, almost identical in size. Earth's diameter? About 7,900 miles. Venus, a hair smaller at 7,500. And they're practically neighbors in the vast solar neighborhood, Venus orbiting just 25 million miles closer to the Sun than we do. But that's where the family resemblance ends. It's like one twin became a beach-loving surfer, while the other locked herself in a steam room. Why? That's the billion-dollar question. To answer it, we had to go there. And let me tell you, getting to Venus, it's no walk in the park. Wind the clock back to 1961. The space race is in full swing, with the US and Soviet Union jockeying for cosmic bragging rights. Venus, bright and close, was an obvious target. But of the first 15 missions launched between 61 and 67, only 3 hit the bullseye: NASA's Mariners 2 and 5, and the Soviets' Venera 4.
Destruct command. Repeat, destruct command.
This one apparently blew up.
That's a 20% success rate, folks. Mariner 2, way back in 1962, was our first success story. It cruised by Venus, 21,600 miles away, and what it found shocked everyone. No magnetic field like Earth's. And the temperature? A blistering 800 degrees Fahrenheit. Scientists were floored. This wasn't the balmy sister world they'd imagined. But the Soviets weren't about to be outdone. In 1967, their Venera 4 probe did something incredible. It plunged into Venus's atmosphere, the first spacecraft to measure the conditions on another planet directly. The data it beamed back was mind-boggling. The atmosphere was 96% carbon dioxide, with surface pressures 90 times Earth's. It was like being a mile deep in our oceans. Then came 1970, a landmark year. The Venera 7 lander, a tough little probe built by the Soviet NPO Lavochkin Design Bureau, did the unthinkable. It became the first spacecraft to land on another planet and send data back. Sure, it only survived for 23 minutes in those hellish conditions, but those were 23 minutes that changed our view of the cosmos forever. Imagine being Venera 7. You've traveled millions of miles through the cold void of space. Now you're dropping into an atmosphere so thick, it's like swimming in hot soup. The heat is rising, the pressure building. When you finally hit the ground, it's like you're caught in a trash compactor inside a blast furnace. Yet, for 23 precious minutes, you hold on, transmitting data that tells a story no one expected. We thought Venus would be Earth's gentle twin. Instead, we found a sibling with a mean streak, a planet that could melt lead on its surface. If you're liking the video so far, you should consider subscribing to the channel and help us create better content and reach more explorers out there. Now back to the video. Ever tried to see through a thick fog? That's what looking at Venus in visible light is like. Those iconic images of a smooth mustard yellow ball, they're hiding more than they're showing. It's like Venus is playing a cosmic game of peekaboo, and for the longest time, she was winning. See, Venus is wrapped in a cocoon of clouds so thick they reflect about 75% of the sunlight that hits them. That's why Venus outshines every star in the night sky except the sun. But it also means that traditional telescopes and visible light cameras are pretty much useless for seeing the surface. It's like trying to read a book through a blanket. Enter infrared technology, our cosmic X-ray specs. Infrared light can penetrate where visible light can't, revealing a whole new Venus. Take a look at images from the Japanese spacecraft Akatsuki. In infrared, Venus transforms from a bland billiard ball to a dynamic world of swirling patterns. Those dark bands? They're the infamous sulfuric acid clouds that visible light can't distinguish. But the real showstopper is the heat. In infrared, Venus glows like a hot coal. That's the greenhouse effect on steroids, thanks to an atmosphere that's 96% carbon dioxide. It traps heat so effectively that Venus's surface temperature skyrockets to around 864 degrees Fahrenheit, hot enough to melt lead, remember? This infrared glow is our first real glimpse into the inferno below the clouds. And there's more. Way up high, around 60 miles above the surface, infrared cameras catch something unexpected. A faint blue glow. It's air glow, caused by oxygen atoms emitting infrared radiation. It's like Venus has a halo, a gentle reminder that even in the harshest environments, there's beauty to be found. But wait, there's another color in our cosmic crayon box. Ultraviolet. UV images from Akatsuki show Venus in yet another light. The clouds that look uniform in visible light now show splotches and streaks of darkness. It's like looking at a black light poster. Features invisible in normal light suddenly pop. What's causing these dark patches? That's the million-dollar question. Scientists are still debating which chemicals or combination of chemicals absorb UV light this way. So here we are, peering at Venus through a kaleidoscope of wavelengths. Visible light gives us the postcard version. Infrared shows us the heat and the hidden currents. Ultraviolet adds intrigue with its unexplained dark patches. Each wavelength adds a layer to the story, turning a simple yellow ball into a complex, dynamic world. From now on, we're hitching a ride with Venera 7. It's 1970, and we're about to take the craziest elevator ride in the solar system, straight down through the atmosphere of Venus. Trust me, this is no ordinary descent. It's a journey through Dante's Inferno with a sci-fi twist. As Venera begins its plunge, we start in what you might call the fake-out layer. From about 155 miles, or 250 kilometers down to 37 miles, or 60 kilometers, it feels almost normal. The temperature? A chilly negative 37 degrees Fahrenheit to negative 143 degrees Fahrenheit, or negative 38 degrees Celsius to negative 97 degrees Celsius. Cold, sure, but not out of this world. Here, we get our first whiff of carbon dioxide. It's a hint, a warning of the wild ride ahead. Now, we hit the main cloud deck, and things get weird fast. From 37 to 25 miles, or 60 to 40 kilometers up, we're swimming in sulfuric acid. Yes, you heard that right. Those picturesque yellow clouds? They're battery acid. And they're not just sitting there. Winds whip around at a face-melting 223 miles per hour, or 100 meters per second. That's fast enough to circle the entire planet in 4 Earth days. As we drop lower, the acid gives way to clear air. But clear on Venus is like quiet in a heavy metal concert. The temperature? It skyrockets. We're talking 864 degrees Fahrenheit, or 462 degrees Celsius, remember? And the pressure is building. By the time we hit 15 miles, or 25 kilometers up, it's like being under half a mile of water on Earth. Now, let's talk about that pressure, because it does something downright bizarre to our old friend CO2. Around 4 miles, or 7 kilometers up, the carbon dioxide gets compressed so much that it stops acting like a gas. It becomes what scientists call a supercritical fluid. Not quite a liquid, not quite a gas, but a bully that shares properties of both. Imagine trying to walk through warm honey while wearing a suit made of lead. That's kind of what it's like down here. The supercritical CO2 is so dense, those hurricane-force winds from above slow to a crawl, about 3 miles per hour, or 5 kilometers per hour. It's an unearthly calm in the midst of hell. And Venera? It's taking all of this in, beaming data back to Earth with the stoic determination of a cosmic reporter. For 23 minutes on the surface, it endures temperatures that could bake pizzas and pressures that would crush a submarine. Just to give us a glimpse, a toe dip into the most extreme environment we've ever directly measured. This is our closest neighboring planet, our cosmic sister. Yet in every way that matters for life as we know it, it's the evil twin. The greenhouse effect gone mad, clouds of corrosive acid, pressures that turn gases into exotic states of matter. It's like nature decided to take every Earth process and crank it up to 11. But that's why Venera's descent is so epic. It's not just about seeing Venus. It's about feeling it, hostile layer by hostile layer. Through Venera's sensors, we don't just learn facts. We experience a world so extreme, so alien, it stretches the limits of what we thought nature could do. And in doing so, it makes us appreciate the delicate balance that makes Earth not just habitable, but a cosmic miracle. So, we've ridden the elevator from hell with Venera. But once we're on the surface, surrounded by that pea soup atmosphere, what do we see? Not much, it turns out. This is where radar comes in, our cosmic X-ray vision. See, radar waves don't care about clouds. They punch right through that sulfuric acid haze like it's not even there. It's like playing Marco Polo, but instead of yelling Marco, we're beaming radio waves at the planet. The way they bounce back tells us about every hill, valley, and weird geological hiccup down there. The Soviets were the first to play this game with their later Venera missions, 15 and 16, back in 1983. They mapped out Venus with a resolution that could spot features about a mile across. Pretty good for a first date with the planet, right? But the real magic happened when NASA's Magellan probe showed up in the 90s. Magellan was like the Google Earth of Venus. From 1990 to 1994, it mapped a whopping 98% of the surface. And get this, it could spot things as small as a football field. We went from a blurry snapshot to a high-def panorama. And what a view it was. First off, volcanoes. Not just any volcanoes, but mega-volcanoes that would make Earth's look like science fair projects. We're talking lava flows that could cover entire US states. There's even a volcanic peak, Mont Mons, that's about as tall as Mount Everest. Then there are the craters. On Earth, weather and life quickly erase these cosmic scars, but on Venus, they stick around. Yet, strangely, there aren't as many as you'd expect for a planet that's been around the cosmic block as long as Venus has. This tells us something wild. Venus's surface is young, geologically speaking. It's like the planet got a full-body makeover relatively recently, probably thanks to those planet-scale volcanic eruptions. But the real showstopper? Valleys that would give the Grand Canyon an inferiority complex. Take Baltus Vallis, a channel that, if placed on Earth, would stretch from Los Angeles to New York City. It's like a giant cosmic waterslide, except the water was molten rock. All of this paints a picture of Venus as a geological dynamo. A world where the ground bubbles with lava, where craters get swallowed up by fresh volcanic flows, and where canyons carve paths longer than continents. It's an infernal paradise, a hellscape that's bizarrely beautiful once you see past the clouds. And that's the real love story here, between radar and Venus. Without it, Venus would still be that mysterious, cloud-wrapped enigma. But with radar, we've discovered a landscape that's alive, violent, and surprisingly young. But for every secret Venus has spilled, a dozen questions bubble up like lava from its mega-volcanoes. How did two planets, born from the same stellar dust, end up so different? Did Venus once have oceans? Maybe even life? The good news? We're not done looking. In the next decade, a fleet of missions from NASA, ESA, Russia, China, India, and even a private venture are gearing up to dive into Venus's mysteries. Because no matter how hellish, how alien she seems, Venus is still family. And in this cosmic saga, we're just getting to the good part. The universe is filled with mysteries, and one of them is Oumuamua, that has been provoking debates among scientists for a while now. On the video appearing on your screen, we talk more about that. Hope you enjoy it. What new mysteries is humanity going to uncover next? Leave it here in the comments and take the opportunity to like the video and subscribe to the channel for more videos like this.